The first rule of logic: there are several methods of mathematical computation which present this peculiarity that if any mistakes are made, we have only to keep right on and they will correct themselves. Suppose for example that I wish to find the cube root of 2. I set down any three numbers one below another. I add the last two numbers of the column and to the tripled sum add in the number next above those two in the column and set down the result at the bottom of the column. I go on doing that, the longer the better, and then the last number but 1 divided by the last will be 1 less than the cube root of 2. See table on following page. If you sit down to solve 10 ordinary linear equations between 10 unknown quantities, you will receive materials for a commentary upon the infallibility of mathematical processes. For you will almost infallibly get a wrong solution. I take it as a matter of course that you are not an expert professional computer. He will proceed according to a method which will correct his errors if he makes any. This calls to mind one of the most wonderful features of reasoning, and one of the most important philosophems in the doctrine of science, of which however you will search in vain for any mention in any book I can think of, namely, that reasoning tends to correct itself, and the more so the more wisely its plan is laid. Nay, it not only corrects its conclusions, it even corrects its premises. The theory of Aristotle is, that necessary conclusion is just equally as certain as its premises, while a probable conclusion somewhat less so. Hence, he was driven to his strange distinction between what is better known to nature and what is better known to us. But were every probable inference less certain than its premises, science, which piles inference upon inference, often quite deeply, would soon be in a bad way. Every astronomer, however, is familiar with the fact that the catalogue place of a fundamental star, which is the result of elaborate reasoning, is far more accurate than any of the observations from which it was deduced. That induction tends to correct itself, is obvious enough. When a man undertakes to construct a table of mortality upon the basis of the census, he is engaged in an inductive inquiry. And lo, the very first thing that he will discover from the figures, if he did not know it before, is that those figures are very seriously vitiated by their falsity. The young find it to their advantage to be thought older than they are, and the old to be thought younger than they are. The number of young men who are just 21 is altogether in excess of those who are 20, although in all other cases the ages expressed in round numbers are in great excess. Now the operation of inferring a law in a succession of observed numbers is, broadly speaking, inductive, and therefore we see that a properly conducted inductive research corrects its own premises. That the same thing may be true of a deductive inquiry our arithmetical example has shown. Theoretically, I grant you, there is no possibility of error in necessary reasoning. But to speak thus theoretically is to use language in a Pickwickian sense. In practice and in fact, mathematics is not exempt from that liability to error that affects everything that man does. Strictly speaking, it is not certain that twice 2 is 4. If on an average in every 1,000 figures obtained by addition by the average man there be one error, and if 1,000 million men have each added 2 to 2 10,000 times, there is still a possibility that they have all committed the same error of addition every time. If everything were fairly taken into account, I do not suppose that twice 2 is 4 is more certain than Edmund Gurney held the existence of veridical phantasms of the dying or dead to be. Deductive inquiry, then, has its errors, and it corrects them, too. But it is by no means so sure, or at least so swift to do this as is inductive science. A celebrated error in the Mécanique Céleste concerning the amount of theoretical acceleration of the moon's mean motion deceived the whole world of astronomy for more than half a century. Errors of reasoning in the first book of Euclid's Elements, the logic of which book was for 2,000 years subjected to more careful criticism than any other piece of reasoning without exception ever was or probably ever will be, only became known after the non-Euclidean geometry had been developed. The certainty of mathematical reasoning, however, lies in this, that once an error is suspected, the whole world is speedily in accord about it. As for retroductive inquiries, or the explanatory sciences, such as geology, evolution, and the like, they always have been and always must be theatres of controversy. These controversies do get settled, after a time, in the minds of candid inquirers. Though it does not always happen that the protagonists themselves are able to assent to the justice of the decision. Nor is the general verdict always logical or just. So it appears that this marvelous self-correcting property of reason, which Hegel made so much of, belongs to every sort of science, although it appears as essential, intrinsic, and inevitable only in the highest type of reasoning which is induction. But the logic of relatives shows that the other types of reasoning, deduction and retroduction, are not so thoroughly unlike induction as they might be thought, and as deduction, at least, always has been thought to be. Stuart Mill, alone among the older logicians in his analysis of the Pons Asinorum, came very near to the view which the logic of relatives forces us to take. Namely in the logic of relatives, treated let us say, in order to fix our ideas, by means of those existential graphs of which I gave a slight sketch in the last lecture, begins a deduction by writing down all the premises. These different premises are then brought into one field of assertion, that is colligated, as well would say, or joined into one copulative proposition. Thereupon, we proceed attentively to observe the graph. L is just as much an operation of observation as is the observation of B's.1. This observation leads us to make an experiment upon the graph. Namely, we first duplicate portions of it, and then we erase portions of it, that is, we put out of sight part of the assertion in order to see what the rest of it is. We observe the result of this experiment, and that is our deductive conclusion. Precisely those three things are all that enter into the experiment of any deduction: colligation, iteration, erasure. The rest of the process consists of observing the result. It is not, however, in every deduction that all the three possible elements of the experiment take place. In particular, in ordinary syllogism the iteration must be said to be absent. And that is the reason that ordinary syllogism can be worked by a machine. There is but one conclusion of any consequence to be drawn by ordinary syllogism from given premises. Hence, it is that we fall into the habit of talking of the conclusion. But in the logic of relatives there are conclusions of different orders, depending upon how much iteration takes place. What is the conclusion deducible from the very simple first principles of number? It is ridiculous to speak of the conclusion. The conclusion is no less than the aggregate of all the theorems of higher arithmetic that have been discovered or that ever will be discovered. Now let us turn to induction. This mode of reasoning also begins by a colligation. In fact it is precisely the colligation that gave induction its name, drive with Socrates, Jvadiot with Plato, Erquin with Aristotle. It must by the rule of predesignation be a deliberate experiment. In ordinary induction we proceed to observe something about each instance. Relative induction is illustrated by the process of making out the law of the arrangement of the scales of a pine cone. It is necessary to mark a scale taken as an instance, and counting in certain directions to come back to the marked scale. This double observation of the same instance corresponds to iteration in deduction. Finally, we erase the particular instances and leave the class or system sample directly connected with the characters relative or otherwise, which have been found in the sample of it. We see, then, that induction and deduction are after all not so very unlike. It is true that in induction we commonly make many experiments and in deduction only one. Yet this is not always the case. The chemist contents himself with a single experiment to establish any qualitative fact. True, he does this because he knows that there is such a uniformity in the behavior of chemical bodies that another experiment would be a mere repetition of the first in every respect. But it is precisely such a knowledge of the uniformity that leads the mathematician to content himself with one experiment. The inexperienced student in mathematics will mentally perform a number of geometrical experiments which the veteran would regard as superfluous before he will permit himself to come to a general conclusion. For example, if the question is, how many rays can cut 4 rays fixed in space, the experienced mathematician will content himself with imagining that 2 of the fixed rays intersect and that the other 2 likewise intersect. He will see, then, that there is one ray through the 2 intersections and another along the intersection of the 2 planes of pairs of intersecting fixed rays, and will unhesitatingly declare thereupon that but 2 rays can cut 4 fixed rays, unless the fixed rays are so situated that an infinite multitude of rays will cut them all. But I dare say many of you would want to experiment with other arrangements of the 4 fixed rays, before making any confident pronouncement. A friend of mine who seemed to have difficulties in adding up her accounts was once counseled to add each column 5 times and adopt the mean of the different results. It is evident that when we run a column of figures down as well as up, as a check, or when we review a demonstration in order to look out for any possible flaw in the reasoning, we are acting precisely as when in an induction we enlarge our sample for the sake of the self-correcting effect of induction. As for retroduction, it is itself an experiment. A retroductive research is an experimental research, and when we look upon induction and deduction from the point of view of experiment and observation, we are merely tracing in those types of reasoning their affinity to retroduction. It begins always with colligation, of course, of a variety of separately observed facts about the subject of the hypothesis. How remarkable it is, by the way, that the entire army of logicians from Zeno to Whately should have left it to this mineralogist to point out colligation as a generally essential step in reasoning. 2 To return to retroduction, then, it begins with colligation. Something corresponding to iteration may or may not take place. And then comes an observation. Not, however, an external observation of the objects as in induction, nor yet an observation made upon the parts of a diagram, as in deduction, but for all that just as truly an observation. For what is observation? What is experience? It is the enforced element in the history of our lives. It is that which we are constrained to be conscious of by an occult force residing in an object which we contemplate. The act of observation is the deliberate yielding of ourselves to that force martyr, an early surrender at discretion, due to our foreseeing that we must whatever we do be borne down by that power, at last. Now the surrender which we make in retroduction, is a surrender to the insistence of an idea. The hypothesis, as the Frenchman says, c'est plus fort QMOI. It is irresistible, it is imperative. We must throw open our gulis and admit it, at any rate for the time being. 3 Thus it is that inquiry of every type, fully carried out, has the vital power of self-correction and of growth. This is a property so deeply saturating its inmost nature that it may truly be said that there is but one thing needful for learning the truth, and that is a hearty and active desire to learn what is true. If you really want to learn the truth, you will, by however devious a path, be surely led into the way of truth, at last. No matter how erroneous your ideas of the method may be at first, you will be forced at length to correct them so long as your activity is moved by that sincere desire. Nay, no matter if you only half desire it, at first, that desire would at length conquer all others could experience continue long enough. But the more voraciously truth is desired at the outset, the shorter by centuries will the road to it be. In order to demonstrate that this is so, it is necessary to note what is essentially involved in the will to learn. The first thing that the will to learn supposes is a dissatisfaction with one's present state of opinion. There lies the secret of why it is that our American universities are so miserably insignificant. What have they done for the advance of civilization? What is the great idea, or where is a single great man who can truly be said to be the product of an American university? The English universities, rotting with sloth as they always have nevertheless in the past given birth to Locke and to Newton, and in our time to Kiley, Sylvester and Clifford. The German universities have been the light of the whole world. The medieval University of Bologna gave Europe its system of law. The University of Paris, and that despised scholasticism, took Abelard and made him into Descartes. The reason was that they were institutions of learning while ours are institutions for teaching. In order that a man's whole heart may be in teaching, he must be thoroughly imbued with the vital importance and absolute truth of what he has to teach, while in order that he may have any measure of success in learning he must be penetrated with a sense of the unsatisfactoriness of his present condition of knowledge. The two attitudes are almost irreconcilable. But just as it is not the self-righteous man who brings multitudes to a sense of sin, but the man who is most deeply conscious that he is himself a sinner, and it is only by a sense of sin that men can escape its thraldom, so it is not the man who thinks he knows it all, that can bring other men to feel their need of learning, and it is only a deep sense that one is miserably ignorant that can spur one on in the toilsome path of learning. That is why, to my very humble apprehension, it cannot but seem that those admirable pedagogical methods for which the American teacher is distinguished are of little more consequence than the cut of his coat, that they surely are as nothing compared with that fever for learning that must consume the soul of the man who is to infect others with the same apparent malady. Let me say that of the present condition of Harvard I really know nothing at all, except that I know the leaders of the Department of Philosophy to be all true scholars, particularly marked by eagerness to learn and freedom from dogmatism. And in every age, it can only be the philosophy of that age, such as it may be, which can animate the special sciences to any work that shall really carry forward the human mind to some new and valuable truth. Because the valuable truth is not the detached one, but the one that goes toward enlarging the system of what is already known. The inductive method springs directly out of dissatisfaction with existing knowledge. The great rule of predesignation which must guide it is as much as to say that an induction to be valid must be prompted by a definite doubt or at least an interrogation, and what is such an interrogation but first, a sense that we do not know something, second, a desire to know it, and third, an effort, implying a willingness to labor, for the sake of seeing how the truth may really be. If that interrogation inspires you, you will be sure to examine the instances, while if it does not, you will pass them by without attention. For I repeat that I know nothing about the Harvard of today, but one of the things which I hope to learn during my stay in Cambridge is the answer to this question, whether the Commonwealth of Massachusetts has set up this university to the end that such young men as can come here may receive a fine education and may thus be able to earn handsome incomes, and have a canvasback and a bottle of closed Valgiate for dinner, whether this is what she is driving at, or whether it is, that, knowing that all America looks largely to sons of Massachusetts for the solutions of the most urgent problems of each generation, she hopes that in this place something may be studied out which shall be of service in the solutions of those problems. In short, I hope to find out whether Harvard is an educational establishment or whether it is an institution for learning what is not yet thoroughly known. whether it is for the benefit of the individual students or whether it is for the good of the country and for the speedier elevation of man onto that rational animal of which he is the embryonic form. 3. There is one thing that I am sure a Harvard education cannot fail to do, because it did that much even in my time, and for a very insouciant student, I mean that it cannot fail to disabuse the student of the popular notion that modern science is so very great a thing as to be commensurate with nature and indeed to constitute of itself some account of the universe, and to show him that it is yet, what it appeared to Isaac Newton to be, a child's collection of pebbles gathered upon the beach, the vast ocean of being lying there unsound. It is not merely that in all our gropings we bump up against problems which we cannot imagine how to attack. Why space should have but 3 dimensions, if it really has but 3, why the listing numbers which define its shape should all equal 1, if they really do, or why some of them should be 0, as listing himself and many geometers think they are, if that be the truth, of why forces should determine the second derivative of the space rather than the third or fourth, of why matter should consist of about 70 distinct kinds, and all those of each kind apparently exactly alike, and these different kinds having masses nearly in arithmetical progression and yet not exactly so, of why atoms should attract one another at a distance in peculiar ways, if they really do, or if not what produced such vortices, and what gave the vortices such peculiar laws of attraction, of how or by what kind of influence matter came to be sifted out, so that the different kinds occur in considerable aggregations, of why certain motions of the atoms of certain kinds of protoplasm are accompanied by sensation, and so on through the whole list. These things do indeed show us how superficial our science still is, but its littleness is made even more manifest when we consider within how narrow a range all our inquiries have hitherto lain. The instincts connected with the need of nutrition have furnished all animals with some virtual knowledge of space and of force, and made them applied physicists. The instincts connected with sexual reproduction have furnished all animals at all like ourselves with some virtual comprehension of the minds of other animals of their kind, so that they are applied psychists. Now not only our accomplished science, but even our scientific questions have been pretty exclusively limited to the development of those 2 branches of natural knowledge. There may for aught we know be 1,000 other kinds of relationship which have as much to do with connecting phenomena and leading from one to another, as dynamical and social relationships have. Astrology, magic, ghosts, prophecies, serve as suggestions of what such relationships might be. Not only is our knowledge thus limited in scope, but it is even more important that we should thoroughly realize that the very best of what we, humanly speaking, know, we know, only in an uncertain and inexact way. 6. Nobody would dream of contending that because the sun has risen and set every day so far, that afforded any reason at all for supposing that it would go on doing so to all eternity. But when I say that there is not the very slightest reason for thinking that no material atoms ever go out of existence or come into existence, there I fail to carry the average man with me, and I suppose the reason is, that he dimly conceives that there is some reason other than the pure and simple induction for holding matter to be ingenerable and indestructible. For it is plain that if it be a mere question of our weighings or other experiences, all that appears is that not more than 1 atom in million or 10 million becomes annihilated before the deficiency of mass is pretty certain to be balanced by another atom's being created. Now when we are speaking of atoms, 1 million or 10 million is an excessively minute quantity. So that as far as purely inductive evidence is concerned we are very very far from being entitled to think that matter is absolutely permanent. If you put the question to a physicist his reply will probably be, as it certainly ought to be, that physicists only deal with such phenomena as they can either directly or indirectly observe, or are likely to become able to observe until there is some great revolution in science, and to that he will very likely add that any limitation upon the permanence of matter would be a purely gratuitous hypothesis without anything whatever to support it. Now this last part of the physicist's reply is, in regard to the order of considerations which he has in mind, excellent good sense. But from an absolute point of view, I think it leaves something out of account. Do you believe that the fortune of the Rothschilds will endure forever? Certainly not, because although they may be safe enough as far as the ordinary causes go which engulf fortunes, yet there is always a chance of some revolution or catastrophe which may destroy all property. And no matter how little that chance may be, as far as this decade or this generation goes, yet in limitless decades and generations, it is pretty sure that the picture will get broken, at last. There is no danger however slight which in an indefinite multitude of occasions does not come as near to absolute certainty as probability can come. The existence of the human race, we may be as good as sure, will come to an end at last. For not to speak of the gradual operation of causes of which we know, the action of the tides, the resisting medium, the dissipation of energy, there is all the time a certain danger that the earth may be struck by a meteor or wandering star so large as to ruin it, or by some poisonous gas. That a purely gratuitous hypothesis should turn out to be true is, indeed, something so exceedingly improbable that we cannot be appreciably wrong in calling it zero. Still, the chance that out of an infinite multitude of gratuitous hypotheses an infinitesimal proportion, which may itself be an infinite multitude should turn out to be true, is 0 multiplied by infinity, which is absolutely indeterminate. That is to say we simply know nothing whatever about it. Now that any single atom should be annihilated is a gratuitous hypothesis. But there are, we may suppose, an infinite multitude of atoms, and a similar hypothesis may be made for each. And thus we return to my original statement that as to whether any finite number or even an infinite number of atoms are annihilated per year, that is something of which we are simply in a state of blank ignorance, unless we have found out some method of reasoning altogether superior to induction. If, therefore, we should detect any general phenomenon of nature which could very well be explained, not by supposing any definite breach of the laws of nature, for that would be no explanation at all, but by supposing that a continual breach of all the laws of nature, every day and every second, was itself one of the laws or habitudes of nature, there would be no power in induction to offer the slightest logical objection to that theory. But as long as we are aware of no such general phenomena tending to show such continual inexactitude in law, then we must remain absolutely without any rational opinion upon the matter pro or con. There are various ways in which the natural cocksureness and conceit of man struggles to escape such confession of total ignorance. But they seem to be all quite futile. One of the commonest and at the same time the silliest is the argument that God would for this or that excellent reason never act in such an irregular manner. I think all the men who talk like that must be nearsighted. For to suppose that any man who could see the moving clouds and survey a wide expanse of landscape and note its wonderful complexity, and consider how unimaginably small it all was in comparison to the whole face of the globe, not to speak of the millions of orbs in space, and who would not presume to predict what move Morphy or Steinitz might make in so simple a thing as a game of chess, should undertake to say what God would do, would seem to impeach his sanity. But if instead of its being a God, after whose image we are made, and whom we can, therefore, begin to understand, it were some metaphysical principle of being, even more incomprehensible, whose action the man pretended to compute, that would seem to be a pitch of absurdity 1 degree higher yet. 7 People talk of the hypothesis where there is a vera causa. But in such cases the inference is not hypothetic but inductive. A vera causa is a state of things known to be present and known partially at least to explain the phenomena, but not known to explain them with quantitative precision. Thus, when seeing ordinary bodies round us accelerated toward the Earth's center and seeing also the Moon, which both in its albedo and its volcanic appearance altogether resembles stone, to be likewise accelerated toward the Earth, and when finding these two accelerations are in the inverse duplicate ratios of their distances from that center, we conclude that their nature, whatever it may be, is the same, we are inferring an analogy, which is a type of inference having all the strength of induction and more, besides. For the sake of simplicity, I have said nothing about it in these lectures, but I am here forced to make that remark. Moreover, when we consider that all that we infer about the gravitation of the Moon is a continuity between the terrestrial and the lunar phenomena, a continuity which is found throughout physics, and when we add to that the analogies of electrical and magnetical attractions, both of which vary inversely as the square of the distance, we plainly recognize here one of the strongest arguments of which science affords any example. Newton was entirely in the right when he said, hypotheses non fingo. It is they who have criticized the dictum whose logic is at fault. They are attributing an obscure psychological signification to force, or vis incita, which in physics only connotes a regularity among accelerations. Thus inferences concerning viri causae are inductions not retroductions, and of course have only such uncertainty and inexactitude as belong to induction. When I say that a retroductive inference is not a matter for belief at all, I encounter the difficulty that there are certain inferences which scientifically considered are undoubtedly hypotheses and yet which practically are perfectly certain. Such for instance is the inference that Napoleon Bonaparte really lived at about the beginning of this century, a hypothesis which we adopt for the purpose of explaining the concordant testimony of 100 memoirs, the public records of history, tradition, and numberless monuments and relics. It would surely be downright insanity to entertain a doubt about Napoleon's existence. A still better example is that of the translations of the cuneiform inscriptions which began in mere guesses, in which their authors could have had no real confidence. Yet by piling new conjectures upon former conjectures apparently verified, this science has gone on to produce under our very eyes a result so bound together by the agreement of the readings with one another, with other history, and with known facts of linguistics, that we are unwilling any longer to apply the word theory to it. You will ask me how I can reconcile such facts as these with my dictum that hypothesis is not a matter for belief. In order to answer this question I must first examine such inferences in their scientific aspect and afterward in their practical aspect. The only end of science, as such, is to learn the lesson that the universe has to teach it. In induction it simply surrenders itself to the force of facts. But it finds, at once, I am partially inverting the historical order, in order to state the process in its logical order. It finds, I say, that this is not enough. It is driven in desperation to call upon its inward sympathy with nature, its instinct for aid, just as we find Galileo at the dawn of modern science making his appeal to illum natural. But insofar as it does this, the solid ground of fact fails it. It feels from that moment that its position is only provisional. It must then find confirmations or else shift its footing. Even if it does find confirmations, they are only partial. It still is not standing upon the bedrock of fact. It is walking upon a bog, and can only say, this ground seems to hold for the present. Here I will stay till it begins to give way. Moreover, in all its progress, science vaguely feels that it is only learning a lesson. The value of fads to it lies only in this, that they belong to nature, and nature is something great, and beautiful, and sacred, and eternal, and real, the object of its worship and its aspiration. It therein takes an entirely different attitude toward facts from that which practice takes. For practice facts are the arbitrary forces with which it has to reckon and to wrestle. Science when it comes to understand itself regards facts as merely the vehicle of eternal truth, while for practice they remain the obstacles which it has to turn, the enemy of which it is determined to get the better. Science, feeling that there is an arbitrary element in its theories, still continues its studies confident that so it will gradually become more and more purified from the dross of subjectivity, but practice requires something to go upon, and it will be no consolation to it to know that it is on the path to objective truth. The actual truth it must have, or when it cannot attain certainty must at least have high probability, that is must know that though a few of its ventures may fail the bulk of them will succeed. Hence the hypothesis which answers the purpose of theory may be perfectly worthless for art. After a while, as science progresses, it comes upon more solid ground. It is now entitled to reflect. This ground has held a long time without showing signs of yielding. I may hope that it will continue to hold for a great while longer. This reflection, however, is quite aside from the purpose of science. It does not modify its procedure in the least degree. It is extra-scientific. For practice, however, it is vitally important, quite altering the situation. As practice apprehends it, the conclusion no longer rests upon mere retroduction, it is inductively supported. For a large sample has now been drawn from the entire collection of occasions in which the theory comes into comparison with fact, and an overwhelming proportion, in fact all the cases that have presented themselves, have been found to bear out the theory. And so, says practice, I can safely presume that so it will be with the great bulk of the cases in which I shall go upon the theory, especially as they will closely resemble those which have been well tried. In other words, there is now reason to believe in the theory, for belief is the willingness to risk a great deal upon a proposition. But this belief is no concern of science which has nothing at stake on any temporal venture, but is in pursuit of eternal verities, not semblances to truth, and looks upon this pursuit, not as the work of one man's life, but as that of generation after generation, indefinitely. Thus those retroductive inferences which at length acquire such high degrees of certainty, so far as they are so probable are not pure retroductions and do not belong to science, as such, while so far as they are scientific and are pure retroduction have no true probability and are not matters for belief. We call them in science established truths, that is, they are propositions into which the economy of endeavor prescribes that for the time being further inquiry shall cease. An eminent religious teacher, Dr. Peirce, seems to think that I do not regard with sufficient horror the doctrine that the conception of truth is ambiguous. For in an article in which he holds up several other of my moral failings to public reprobation, he caps the climax by saying that I admire Duns Scotus, who was a man who held that a proposition might be false in philosophy yet true in religion, and names the volumes and pages in the works of Duns Scotus of two passages, which the reader infers would enunciate that position. One of the pages is substantially blank and the other contains nothing remotely bearing on the subject. Duns Scotus may possibly have said something of the kind, but if he did I cannot imagine where it can be hidden away. This however I do know, that doctrine was the distinguishing tenet of the followers of Avahus. Now I know of but one place in all my reading of Duns in which he speaks unkindly of any opponent, and that one is where he alludes to Avahus as is damnatus Avahus. This hardly looks as if he followed him in his main position. But whether the word truth has two meanings or not, I certainly do think that holding for true is of two kinds. The one is that practical holding for true which alone is entitled to the name of belief, while the other is that acceptance of a proposition which in the intention of pure science remains always provisional. To adhere to a proposition in an absolutely definitive manner, supposing that by this is merely meant that the believer has personally wedded his fate to it, is something which in practical concerns, say for instance in matters of right and wrong, we sometimes cannot and ought not to avoid, but to do so in science amounts simply to not wishing to learn. Now he who does not wish to learn cuts himself off from science altogether. Upon this first, and in one sense this sole, rule of reason, that in order to learn you must desire to learn and in so desiring not be satisfied with what you already incline to think, there follows one corollary which itself deserves to be inscribed upon every wall of the city of philosophy. 9. Do not block the way of inquiry. Although it is better to be methodical in our investigations, and to consider the economics of research, 10, yet there is no positive sin against logic in trying any theory which may come into our heads, so long as it is adopted in such a sense as to permit the investigation to go on unimpeded and undiscouraged. On the other hand, to set up a philosophy which barricades the road of further advance toward the truth is the one unpardonable offense in reasoning, as it is also the one to which metaphysicians have in all ages shown themselves the most addicted. Let me call your attention to 4 familiar shapes in which this venomous error assails our knowledge. The first is the shape of absolute assertion. That we can be sure of nothing in science is an ancient truth. The Academy taught it. Yet science has been infested with overconfident assertion, especially on the part of the third-rate and fourth-rate men, who have been more concerned with teaching than with learning, at all times. No doubt some of the geometries still teach as a self-evident truth the proposition that if two straight lines in one plane meet a third straight line so as to make the sum of the internal angles on one side less than 2 right angles, those two lines will meet on that side if sufficiently prolonged. Euclid, whose logic was more careful, only reckoned this proposition as a postulate, or arbitrary hypothesis. Yet even he places among his axioms the propositions that a part is less than its whole, and falls into several conflicts with our most modern geometry in consequence. But why need we stop to consider cases where some subtlety of thought is required to see that the assertion is not warranted when every book which applies philosophy to the conduct of life lays down as positive certainty propositions which it is quite as easy to doubt as to believe? The second bar which philosophers often set up across the roadway of inquiry lies in maintaining that this, that, and the other never can be known. When Auguste Comte was pressed to specify any matter of positive fact to the knowledge of which no man could by any possibility attain, he instanced the knowledge of the chemical composition of the fixed stars, and you may see his answer set down in the philosophic positive. But the ink was scarcely dry upon the printed page before the spectroscope was discovered, and that which he had deemed absolutely unknowable was well on the way of getting ascertained. It is easy enough to mention a question the answer to which is not known to me today. But to aver that that answer will not be known tomorrow is somewhat risky, for oftentimes it is precisely the least expected truth which is turned up under the plowshare of research. And when it comes to positive assertion that the truth never will be found out, that, in the light of the history of our time, seems to me more hazardous than the venture of André. The third philosophical stratagem for cutting off inquiry consists in maintaining that this, that, or the other element of science is basic, ultimate, independent of aught else, and utterly inexplicable, not so much from any defect in our knowing as because there is nothing beneath it to know. The only type of reasoning by which such conclusion could possibly be reached is retroduction. Now nothing justifies a retroductive inference except its affording an explanation of the facts. It is, however, no explanation at all of a fact to pronounce it inexplicable. That therefore is a conclusion which no reasoning can ever justify or excuse. The last philosophical obstacle to the advance of knowledge which I intend to mention is the holding that this or that law or truth has found its last and perfect formulation, and especially that the ordinary and usual course of nature never can be broken through. Stones do not fall from heaven, said Laplace, although they had been falling upon inhabited ground every day from the earliest times. But there is no kind of inference which can lend the slightest probability to any such absolute denial of an unusual phenomenon.